Hey physics people, time for another dynamics physics problem, this one on static friction. A force of 46.0 newtons is required to start a 4.8 kilogram box moving across a horizontal concrete floor. A, what is the coefficient of static friction between the box and the floor? And B, if the 46.0 Newton force continues, the box accelerates at 0.69 meters per second squared. What is the coefficient of kinetic friction? So first things first, with a problem like this, start with a free body diagram. Okay, so we've got a box on a concrete floor. The picture really doesn't get much simpler than that. Okay, so there's your floor, there's your block. Okay, now to draw the forces coming out of it, the box obviously has some weight. So there's a force of gravity going down. It's sitting on a surface, so the normal force is pushing back up, perpendicular to the surface. The box is pushed, so I'm going to assume it's getting pushed to the right. And the frictional force is going to oppose this. Okay, so notice though, in my free body diagram, I'm not going to put static friction. I'm just going to put force of friction because in part B, it's not static anymore, it's kinetic, although the free body diagram will look the same. Okay, so if you want to identify this as static, you can put FFS, kinetic, FFK. Okay, so we know for static friction that according to Newton's third law, when an object is not moving, when you apply a force onto it, it doesn't move necessarily if there's static friction acting on it. And according to Newton's third law, however much the push force is, that's how much the static friction will be until the point that you break the seal between the floor and the box. Okay, you break that maximum static friction. And maximum static friction is given by this formula, okay, FFS max. It's given by the coefficient of static friction, mu s, times the normal force. Okay, so we're going to be making use of that formula here. But there's a couple of things that we also have to identify here. First is that the box is not accelerating up or down. Okay, so therefore, since F net y is equal to 0, we can say that Fn, the normal force, is equal to the magnitude of the gravitational force. Okay, now the other thing, okay, so for part A, the box is not accelerating vertically, but it's also not accelerating horizontally. Now, although we just get the box moving, these two forces are going to be constant with each other. We know that because it's not until part B that they identify that there's an acceleration. In part A, there's no acceleration, therefore there's no net force. So we can say F net x equals 0. And in the x direction, so let's put our coordinate axes here, x and y. In the x direction, we've got Fp in the positive, F friction in the negative. So therefore, if F net x equals 0, the force of static friction has to equal the push force. Okay, so that's the premise that we are going to start with. So let's do that here. Okay, so FFS is equal to Fp, right? And the maximum static friction, which is what we're dealing with here, okay, that's mu s Fn is equal to Fp. Okay, now we're looking for mu s. That's our unknown here. Fn, okay, so the fact that we said F net y is 0, we could conclude that the normal force and the gravitational force equal magnitude, opposite in direction. And we know that Fg is just mg. And there's no other vertical force here. So I'm going to replace Fn with mg. Mu s mg equals Fp. And again, since we're actually trying to solve for mu s, I'm going to rearrange this expression for mu s. Okay, so mu s is equal to Fp over mg. So if we plug in our numbers, the force that is getting pushed with is 46.0 newtons divided by the mass, okay, 4.8 kilograms times acceleration due to gravity, 9.8 newtons per kilogram. Okay, remember, acceleration due to gravity has two units that work, meters per second squared and newtons per kilogram. Okay, I use this one here because the kilograms cancel, newtons over newtons cancels, and that leaves us with a unitless quantity, mu s, which is exactly what we want. Okay, so we end up getting mu s is equal to 0.98. Okay, now something you got to do, always check to make sure your answer makes sense. This number here always has to be less than 1, okay, unless, of course, you're dealing with a metamaterial. But For the cases in high school, you're only going to be dealing with 0.98 is the coefficient of static friction, okay? Something less than 1. Okay, so that takes care of part A. And now it's time for part B, but part B is actually quite similar. Okay, so now this 46 Newton force continues, right? And we know that static friction, that maximum static friction is greater than kinetic friction. Once you push and push on a heavy object and it finally starts to move, it starts moving fast. You don't have to apply the same force just to keep it going at a constant speed. But here, they're continuing with that 46 Newton force. And that's why the box is getting faster and faster. It's accelerating at 0.69 meters per second squared. Okay, so to find the coefficient of kinetic friction, okay, so now instead of static friction, we've got kinetic. So that still implies the free body diagram is the same, except FF is now FFK. Okay, so we're just going to play around with it like that. Okay, now, so that was the answer for A. For part B, we've now got an acceleration. So the difference is, in part A, we said F net x equals 0 because it's not accelerating. Here, we're going to have to say F net x equals max. Okay, so now, acceleration, and we'll say AX, just to keep the letters straight. AX is equal to 0.69 meters per second squared, and we are tasked with finding mu k. All right, so we start off with our Newton's second law. This is honestly the best way to solve a problem in physics. Anytime you have forces, if you don't know anything what to do in the problem, just do F net equals ma. It's going to get you halfway there. Okay, F net x equals ma. Now we do our same. Push force minus force of kinetic friction equals max. Okay, we're looking for mu k. Now where's mu k coming out of? Well, recall before I said the maximum force of static friction is mu s Fn. Okay, so similarly, the force of kinetic friction is equal to mu k Fn, the coefficient of kinetic friction times the normal force. Okay, so we're going to replace FFK with mu k Fn. So Fp minus mu k Fn equals max. And similar to before, okay, although the net force in the x direction is not 0 anymore, the net force in the y direction is. It's still 0. The box is not going up and down. Okay, so that means that Fn is the same as Fg, which is mg. Okay, so I'm going to now replace that. Fp minus mu k mg equals max. Okay, now let's do this. How can we rearrange this? Let's bring the mu k mg on the right to make it positive. Let's bring the max on the left, right? Because we're solving for mu k, we want it to be positive. Okay, so Fp minus max equals mu k mg, right? So now to get mu k by itself, you divide both sides by mg. So, and I'm also going to switch the sides just so mu k is on the left. So nothing else is changing. I'm just going to divide both sides by mg. Okay, so then I get mu k equals Fp minus max over mg. And again, I say this in my previous problems as well, but in physics, when you're solving a problem, you don't want to plug in the numbers right away because there's a lot of chance that a lot of things might cancel out variables. Okay, so it's a good habit to just write it as the letters first, the variables, and then you can plug your numbers in at the very, very end. Okay, so Fp is 46 newtons, so plug that in, minus the mass, 4.8 kilograms, acceleration, 0.69 meters per second squared, divided by the mass again, 4.8 kilograms, times g, 9.80 meters per second squared. That's it. You just have to plug this in your calculator, and if you don't make any mistakes with that, then you should end up getting your final mu k value of 0.91. Okay? Now, a last check. Make sure your answer makes sense, okay? So again, I said this number should be less than 1, and there's one other thing you need to check for, and that is that your mu k is less than your mu s. Okay, so remember I said that the force to keep an object going after you've broken that maximum static friction is less, and therefore the coefficient for that force must be less as well. The coefficient of kinetic friction should be less than that for static, and it is. So our answer does in fact make sense. Okay, so that's it for this video, guys. Be sure to click that like button and subscribe to Physics in the Flesh so you catch my new videos, which come on every weekday at 12 noon. All right, guys, enjoy the rest of your day, and I will catch you in the next video.